if you weren't here or if you are 100% remote. So first of all, to do the atomic structure PhET, you're going to need the links. You could either get the links from here, or I'll show you where to get them within the lab. Okay, so we are completing the lab that is here. You guys are going to click on the assignment and open up your lab document. And when you get to your lab document, okay, the very first slide is just kind of an intro video. You're welcome to watch that. We watched it in some of our classes together. Okay, the second slide, you are using the periodic table to fill in the missing boxes here, so the boxes that are in blue. Okay, so what I'm going to do is I'm going to click on the periodic table, open the periodic table up so that I can go back and forth. First of all, there's some really important information on the periodic table. First of all, it tells us the atomic number equals the number of protons, and that equals the number of electrons. The second key number that's on here is the atomic weight. Atomic weight is another name for atomic mass or mass number. So those are used interchangeably. So the atomic weight is the number of protons plus the number of neutrons. So if our atomic weight is 12 and our atomic number is 6, to find the number of neutrons, we would take the weight or the atomic mass of 12 in this case and subtract the atomic number 6, and that would give us the number of neutrons. Okay, so let's look at another example. Okay, if we are looking at iron, okay, iron symbol is Fe right here. Okay, iron has an atomic number of 26. That means that iron, the neutral atom of iron, has 26 protons and it has 26 electrons. So those will be equal. Okay, then 56 is the number of protons plus neutrons. That's the mass. So to find the number of neutrons, I would take 56 minus 26. 56 minus 26 is 30. So that is how many neutrons there are in an iron atom. Okay, so that's how you can use the periodic table. Down here at the bottom, there's a key that tells us a little bit more about our element. So we might find out that our element is a solid or a liquid or a gas at room temperature. We might find out that it's radioactive or it's artificially or man-made. Okay, the other thing you can do is actually click on an element. And when you click on the element, you'll get more information about that element, so a lot more detailed info. Okay, so you might use that at the end of the lab. Okay, so here's my periodic table. Okay, I'm going to keep that open so I can use it, and I'm going to go back and forth. Okay, here I've got boron. Boron has 5 protons, 6 neutrons. I need to find out how many electrons. Okay, I use my periodic table to remind me the number of electrons equals the number of protons, and that equals the atomic number. So I should be able to fill out this first box. Protons and electrons are equal. Okay, in the second row, we're given neutrons and electrons, so we have to work backwards. We know the number of electrons. If the number of electrons is equal to the number of protons, we would have 4 protons, and then we would need to find out what element has 4 protons. Okay, well, the element that has 4 protons has an atomic number of 4, right? So number of protons, if that equals 4, the atomic number equals 4. So I'm looking for the number in this upper left-hand corner to be the number 4. So those numbers go in order. So they go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So they increase as you go across the board, okay, from the left side to the right. And here is 4. So the element that has 4 protons is beryllium. Beryllium. Okay, so I can fill in my second row here with the element name. Okay, then I get down to carbon. Again, I'm using that key information about the number of protons and electrons being equal. Okay, the next row, I'm trying to find out what element has 2 protons. Okay, and how many electrons would it have? And then nitrogen, okay, has 7 protons. How many electrons would it have? Okay, then you move on to the second part. In the second part, you're going to use the build an atom PhET. So you click on that link at the top of this slide. So this is slide 3. When you click on it, it's going to bring you to this page. Click play, and then select the Atom tab. Okay, once you have the Atom tab created, Okay, you are using that PhET to help you build some of our atoms. Okay, so again, you're filling in the missing boxes here, and then you're going to build your atom here. So essentially, you are building it, in the PhET. Okay, and then once you have it built in the PhET, you'll do the same process here on the lab. Okay, so some of it you should be able to do just kind of by knowing, okay, or by looking at the information that's given to you. Some of it you are going to need the PhET to clarify. Okay, they tell us in this slide that we have boron. Boron has 5 protons and 6 neutrons. So I'm going to click on my protons. I'm going to Control C, copy, Control V, paste, and then I'm going to bring it up into the nucleus, and then I'm going to copy it and paste 4 more. 1, 2, 3, 4. Okay, now I have the number of protons I need. Okay, I also need 6 neutrons, so I Control C, Control V. I now have my neutron. I'm going to move that up here, and I need 6 of these. So Control C, 1, 2, 3, 4, 5. Now I have 6 of those. Okay, and then I can arrange them so that they're actually kind of like in a nucleus, like in a circle. Okay, so we can move those around, okay, to form an actual nucleus. Okay, it doesn't have to be perfect, okay, but something close to a spherical shape. Okay, the last piece is how many electrons. Number of protons equals number of electrons. So the number of electrons is going to be 5 because that's how many protons we have. Okay, and then I'm going to use my PhET to build this. Okay, so I've got 1, 2, 3, 4, 5 protons. So I've got boron. I'm going to put in 6 neutrons. 1, 2, 3, 4, 5, and 6 neutrons. Okay, and then I need my atom to balance out. So instead of being a positive ion, I want it to be neutral, and I'm going to add electrons until it's neutral. Okay, and if we keep in mind that protons are positively charged, electrons are negatively charged, so I need to balance out the positive and negative charges. Hey, it's not balanced yet. I'm going to keep adding electrons until it is balanced. There we go. Now it's balanced. It's called a neutral atom. So I have 2 electrons in the inner ring and 3 electrons in the outer ring. Okay, so again, back to here, Control C, Control V. I've got my electron. Okay, copy, paste it. Okay, and 1, 2, 3 more. Okay, so I have a total of 5 electrons. Okay, now my atom's been built. Okay, I need to know the atomic number, the symbol, and the atomic mass for boron. Okay, so I can find that on my periodic table. I could go to the periodic table, find boron, element number 5. Okay, its atomic number is 5, its atomic mass is 11. Okay, so I'm going to plug in that information here, and its symbol is B. Okay, you'll follow that same process for the next several slides. You're just given different information on each of them, and they refer back to the elements that were here on this first table. Okay, the second part, you are looking at elements that are found in our body. Okay, so some of the elements we haven't talked about yet. So hydrogen, oxygen, phosphorus, and sulfur. You're going to figure out the number of protons, neutrons, and electrons in each of those elements. You'll use the periodic table to do that. Again, you'll use this information, protons equals electrons. Atomic weight is protons plus neutrons. So to find the number of neutrons, you'll take, in this case of manganese, you'll take 55 minus 25, and that would tell you how many neutrons. Okay, the last element, you are choosing your own, so you're going to put your own element in there. Okay, then we've got some simple questions for you to answer. Which element was the largest and heaviest? So which one had the greatest atomic weight out of all the elements that you looked at in the lab? And that includes the one that you chose. How do you determine the number of electrons using the periodic table? Okay, so what information here on the periodic table tells us about the number of electrons? Which element is the simplest and lightest and smallest? That's the one that has the smallest or lowest atomic mass out of all the elements that we looked at. How is the mass number of any element determined? Mass number is the same as the atomic weight. So again, go back to your periodic table. How do we find atomic weight? And then the last question, how do you determine the number of protons in any element in the periodic table? Again, go back to the periodic table, use this information up at the top. Okay, then your last two slides you're comparing. You're going to choose two elements. Add a text box. Tell me what your first element is. Okay, so if you're choosing carbon, go ahead and write carbon on here. Okay, grab another text box. Tell me what your second element is. Maybe it's sulfur. Okay, and then can't spell. Okay, so those are your two elements. Then you're going to put differences on either side and similarities between the two elements in the middle. The similarities are going to be things like they're both atoms, they both have protons, they both have neutrons, they both have electrons, they both have a nucleus, they both have an electron cloud, okay, things that make them atoms. Okay, mostly they're very different, okay, because all of our elements are unique and they have unique properties. You might, an example of a difference, tell me how many protons are in carbon versus how many protons are in sulfur. And then again, you can come to your table here and click on the element and maybe find some more specific information. So maybe you tell me about the melting point or what period it is part of, and that could be a similarity or a difference. Okay, you also might use, okay, I was using carbon and sulfur. Okay, carbon and sulfur are both metals, so I would put that they are both metals as a similarity. Okay, so you fill out that table. Once you have the table filled out, the last slide, you're taking the information in the table and you're just converting it into paragraph form. Anyhow, I hope that helps you with the atomic structure lab. Please let me know if you have any questions.